Thank you very much for inviting me. It's very much appreciated. Hopefully I can give you an insight into some of Interflon's technology without giving you too many trade secrets. This is basically my day job, going out in track, training engineers on how to best use the products. So I'm not the technical engineer or the boffin behind Interflon. They're based in Roosendaal in Holland, so we're a Dutch company. So a little bit about the technology of the product, but I'm sure anybody who's been out in track is used to seeing this type of application out in track in switches. This has been around for many a year. It tends to be the more grease you put onto the slide stick, the better it is deemed as being performance. And this is typically of Interflon's technology. So this is what we call MicPol technology. So this is a completely different animal from blades and everything up with grease. It's a dry, transparent coating. And the product was originally developed for the Deutsche Bahn 22 years ago. And the reason why the Deutsche Bahn actually wanted something like this was because going out doing track inspections, you can't actually see anything. So this is where Interflon was born 20 odd years ago. And this type of environment and coating is ideal to do any track inspections. So why use MicPol? Well, the first 10 seconds of any machinery moving, you get what we call startup friction, and that's what the red graph here shows here. So the first 10 seconds of movement, say for instance in a switch, you get all the contact between the two surfaces.
Sorry, Rob, can I just ask you, Sarah has asked, can you change your display settings so you can see his notes?
Yeah.
Yeah.
So at the moment we're seeing you in presenter view.
Yeah.
Sorry, it's always tries to be crazy, wasn't it? Me as well. Just bear with me. Right, so you want to go to slideshow, take presenter view off, and then is that F5? I can't see.
Is it down here? Is that better?
Yeah.
Yeah,
Yeah, that's it.
I'll quickly go back then. Yeah, so again, this is what you're traditionally used to seeing out in track. Copious amounts of grease, not ideal to do a track inspection. And this is what you're going to see with Interflon's technology. That's in virtually all our technology. It's completely transparent coating, ideal for the PLPR train that's out on track to be able to inspect. That's again an idea of where Interflon can be used to look for any defects in any components out on track. But this is a lot more helpful when it comes to detecting any cracks or issues on track. So again, going back to the graph, any machinery that moves, you get this initial startup peak, and this is where 80% of the wear is caused within the first 10 seconds. Because obviously you've got no fluid film between the two surfaces, you've basically got two materials resting on top of one another. If you actually use MicPol technology, it actually gets away with this because you've actually got a physical film between the two surfaces. You actually get to the green line here, which obviously then increases your asset life, etc. This is typically of what you would have with standard lubricant. So this is where you've got the two surfaces resting together. It's not until you actually get to full fluid film that you get a full separation of the two surfaces. But then, of course, as loads and speed starts to change, lateral loads when trains come through, you get back to this scenario. And this is again where you pick up a lot of wear of your assets. If you're going to make assets last longer, you need to be able to have that protection at startup. Interflon now is very, very differently. So we just don't rely on oil to lubricate and give you the fluid film. We actually have solid material particles in there that are less than the size of a hair follicle. So if an hair follicle is 80 micron, we're milling our products down to 0.1 of 1 micron. Okay, that then fills all the asperities within the surface, whether it be plastic, brass, bronze, steel, but also more importantly, it leaves a full micron layer, a hard fused layer to the surface. So you get rid of all the startup friction and all the wear. So this is just a little story. Hopefully you can hear this with audio of Interflon.
Have you ever realised that if you always do what you've always done, you'll always get what you've always got? This is the Interflon story. A story about the need to innovate. 3500 BC, humanity came up with a brilliant idea. an invention that would change the world by making a centered hole in the cylinder and adding an axle. That would enable heavy transport, but its use also meant friction. So after 1,500 years, we added spokes, but this didn't eliminate friction. And when the wheel evolved to gear complex machinery and even more friction, even the discovery of lubricant didn't fully solve it, because the fluid didn't stick to the metal surface, still resulting in wear and ultimately breakdown. Then in the year 1980, reinforcements came up with a visionary idea. It created micronized particles that fill up the microscopic notches in metal. By polarizing these particles, they stick to the surface, leaving an impenetrable film layer over grinding parts. It called this unique technology MicPol. MicPol significantly reduces wear, lubricant usage, and significantly reduces CO2 emissions. His invention became a vision, named Interflon, a vision reframing technical maintenance all over the world, making any machine a better machine. Embrace innovation to benefit tomorrow. Interflon.
Okay, so MicPol is a process of particles. That's what Interflon specialise in, being able to break into particles and actually get them to stick to whatever we want to put that to. That can be any material, glass, plastic, brass, bronze, you name it, it can stick to it. And as you saw there in the video, we micronise the particles to such a size we can actually fill all the cavities up in the metal spherities and leave this bonded layer behind. So we'll now go through what I know of Interflon, because again, it is a trade secret. So it's developed in-house by a team of scientists. We're actually owned by scientists. There's no commercial people in our business. It's owned by scientists. One of the chief chemists for DuPont, a gentleman called Dr. Wim Horsmans, was our founder. Okay. So we use micronization and polarization. What does that mean? It means that we micronize things down to such a small level, but then we break into the particle and we make it sticky. We make it being able to stick to a material, but it doesn't stick to itself. It aligns with itself. Okay. We've also, Interflon's got R&D recently found other more sustainable solids, because originally Interflon was known for Teflon. Okay. Teflon obviously is a microplastic. We've been working on this technology for years, where we've moved away from that. Now we've moved into the mineral organic materials that we've been pioneering for a number of years. So that's what we use, particularly in our products. At the same time, the improving on technology by polarizing the base oil as well. So not only are we actually getting the actual materials to stick to the substrates, we're actually polarizing part of the fluid as well, the carrier product, which actually gives you a stronger bond. Some of the tests that have been done in the past, more recently, we've actually seen an enhanced performance than where we was, say, 5-10 years ago. And it penetrates even deeper into the pores and also forms what we call a bonding bridge. Okay, so between the solids and the rest of the lubricant, so it'll last longer as well. We're now starting to see some tests that we've done in Network Rail, where originally they've gone from weekly or twice weekly lubrication using standard products into using Interflon, and now going 4 weekly. We're now using this technology, we're now going to be doing 8 weekly between lubrication intervals. So again, by having that technology, we can actually increase or decrease the lubrication intervals and obviously make the assets last longer as well. So it helps with metal to metal contact and stick slip, as we call. It's also weather resistant as well. Whatever you chuck at it, we apply this product out in Taiwan that has horrendous weather conditions. This product's completely water resistant. Okay. Likewise, it's hydrophobic. So if you've got ice adhesion, it's not actually going to stick to this product whatsoever, because obviously you've got this hydrophobic layer. And also as well, what's also important is what tends to kill lubricants is UV light. This product is completely resistant to UV light, so it can't deteriorate as well. It is biodegradable, 98% biodegradable. But what I will remind people is, to get something to biodegrade, it needs to fall into the floor where there's the organisms, so the ground. So wherever it sits on the assets, it's not going to degrade. It's only going to degrade when it falls into. So a little bit of the story of Network Rail and where Interflon came. So Interflon UBP, as I mentioned earlier, was developed for the German railway back in 2000. The scope was to develop a dry film, all-weather, transparent lubricant that would improve performance and reduce failure. It was a big ask, and it took a lot of development, but we got there. Interflon was introduced into Network Rail in 2008 on S&C high drives. So these were the high-speed switches that were actually installed on the West Coast main line. It spent £9 billion on the upgrade, and was having problems with these hard drive switches. There was actually going to spend another £50 million trying to improve the problem. When I actually got to meet a gentleman called Neil Denton. I'm sure a lot of you will know Neil Denton. He's part of the PWI as well. Does quite a lot of seminars. So Neil met us and thought it was a great idea. So we first got introduced back in 2008 on the West Coast main line. The testing was carried out by senior engineers within Network Rail, so including the chief engineer now, Martin Jones, was pivotal in testing the product, but it was tested by Network Rail, it wasn't tested by us. We actively encourage the people to test our technology themselves, because it's all right saying us saying that we've got the best thing that's going to work on your asset, and you've got to really prove it to yourself. The product was approved after 2 years of senior engineers testing on all routes. It was quite a quick product approval, really, 2 years. And these are just a couple of graphs. So the first graph in the top corner here was on the West Midlands. You can see all the failures in the form of the different colours here. You can see these failures are mounting up. Interflon was applied here at the top one, here on the second one, so on and so forth. But what you actually see is the failures just plateau. It clearly shows you that Interflon had a quite significant difference to the performance of those assets. Likewise here, these are the high-speed switches. This was in L&W South. The number of assets are here in purple. The blue line is actually the failures that those assets are causing. But as you can see, the more assets that get introduced, the failure goes up and up and up. The yellow line is when Interflon was actually introduced.
Sorry, not good.
Okay, so the yellow line here, sorry, you can see the Interflon was first introduced. This is quite interesting. The more assets it's actually applied on, the failures come down to virtually zero. So again, showing you that the technology had a big influence on the performance of those high-speed switches. Also, Schwehag, everybody knows Schwehag for rollers. They're independent. They've got a special machine that does a lot of the testing. And what they wanted to find out, or what Network Rail wanted to find out, was what was the difference between this coating and another coating. So molybdenum is a coating that Schwehag use. It's a coating that's used on a lot of different asset types. And this machine actually simulates a switch. So this particular one here, they actually put an extra 300 kilos of load on the switch rail. They put it on a cant, and they actually introduced humidity into the chamber as well, so they can actually simulate any time of the year. What they found was that the friction started here, 0.5. By the time it had done 20,000 movements, the friction had been that high that the rig failed. Okay, so you could say that molybdenum is good for 20,000 movements, but the friction does increase from the first movement. However, with Interflon, it surpassed 20,000 movements and went to 70,000 movements. And that friction coefficient is a lot straighter line than this one here. If I just add that over the top, just to give you an idea, the friction starts here on a molybdenum plate and here on an Interflon plate. So you can clearly see, again, the coating has a significant effect to friction levels. It's also very constant as well. This is a London Underground. This was testing rollers and Interflon and to see what benefits you would have with one or the other or both. And what they found here, because they actually use air pressure in the tunnels underground, they needed quite a large headroom between their pressures to actually move switches. So if you got added weight or added problems in a switch, your headroom was X amount of air pressure. They wanted to increase that. What they found was if they just used Interflon alone, it dropped from 47 psi to 32 psi. And if you did rollers and on its own, it dropped from 47 psi to 24 psi. Obviously, rolling friction is much lower than sliding friction. However, if you put the two together, there's an advantage. It drops from 47 psi to 20 psi. And again, a lot of people will say, well, if you're using Schwegs rollers on layouts, you don't need to use lubricant. Actually, that's proved that you can actually add added benefits of using the product. Plus, as well, you have to remember that the heel section, the bit that doesn't move at the back of the switch, you can't get a roller under that position there. That's purely where you're relying on low friction. And again, it says here, do not provide any significant lift between the head cut and the heel. So only Interflon can deliver any benefits in that area. So from the fixed position at the back of the switch, you're purely relying on low friction, and that's where Interflon can benefit. There's also another benefit, as we've learned over the years of working with Network Rail, particularly the S&T guys, is that you can also have a problem as well when a switch rail falls off a roller and back onto the slide share, because it's still potentially got 4 or 5 mil of fit up before you actually get detection. And at that point, you can actually get a lot of the switch back onto the slide share, and you can get high friction. So we've seen a big benefit of putting it all the way through Schweg layouts. Okay, so Network Rail have also done a RIA called RIA 34. So if you actually go onto the system, a RIA stands for Reliability Improvement Alert, and this is all around lubrication and performance and switches. So there is actually a document under RIA 34 that you can find, which is a Network Rail written document about our product and performance improvement. There's also a comprehensive book as well. For those that are in the room, they've all got one of these. But actually, this actually tells you about all the procedures of how to use our product, how to track. At the back page, we've also put a QR code. So if anybody scans their mobile device over that QR code, it will actually take to that booklet. Likewise, if you've not seen me or anybody from Interflon over the next 5 years, if you constantly go to that QR code, it'll give you the latest upgraded book. So quickly showing you how this product is actually applied, because traditionally you'd use a bucket, a Turk brush, and you blast everything with grease. Yeah, so very quickly to apply, you're looking at 1 minute through an average C switch. You also notice as well the switch actually wasn't reversed. Don't need to. This product will actually use capillary action to actually get under the switch and into the heel section. The other thing with the product as well, it's showing you at the end there, applying the product to the wet condition, because we call this a dry film product. You can apply it in wet conditions, and it can take contamination straight away and just brush it straight off. So that actually was dry sand. You'd expect a wet lubricant attracted to a dry sand, you'd expect a grime in place. Quite the opposite with this particular product. And also as well, you only actually put on 1 teaspoonful per slide share. You don't put much product on there, so it doesn't make itself into the ballast, so it won't need to degrade because it doesn't get there. The other important stuff about this product as well is it's not designed to migrate to the rail pad. A lot of people don't think about the rail pad, but if you get lubricants onto a rubber rail pad, you can get what they call delamination. Okay, and delamination is not ideal in a switch, particularly when you come to the toe load on a clip. If you actually degrade the pad by 5 mil, whatever the pad size is, you're actually taking the toe load off the clip. So again, Interflon's not designed to actually migrate to the rail pad. Again, this is just giving you further evidence. These are the high drive switches. This graph here is from their RCM system. What you can see here is the green line is the reference point. So what you've got here is you've got the motor spooling up, then the switch starts to move. It's got its transit time, and then it's got its fit up at the end and its full lock-on detection. These are the seconds at the bottom here. So the green is the reference prior to using Interflon. Brown actually is the cleaning process. Actually, this is starting to clean off any rust from underneath the switch. And the final blue line here is the day after it's completely dried. And we're not between 1 and 2 seconds of actually a switch. So again, it not only reduces the friction, but it can also reduce the time to throw as well. And on the RCM graphic clearly showing you there was a 30% reduction in the power needed to throw the switch. We've done this consecutively throughout different types of switch lengths and switch types we'll actually use the product. Again, another graph here. This is again from Martin Jones. So the blue line here is showing your failures. The red line here is actually showing your failures using Interflon. The failures using traditional is blue, Interflon is red. But as you can see, the more ends that Interflon go on, the failures come virtually right down here. But what is important is these 2 humps here. That's because they actually run out of product to put on the side chairs. So again, it clearly shows you when you don't run out of the product, you can get to 0 failures. And again, this is the mean time between failures. So this is where they was prior to Interflon in the blue, and the yellow is using the Interflon there. So Bristol DU on your patch. This was from Dan Collins. So this is going back to 2015, 2016. So they saved in failure costs over a 3-year period, £1.3 million. Sometimes call that wooden money because it doesn't come out of your part, but still it's a saving there, £1.3 million. But more importantly, less point failures, 627 less point failures by using the technology. Again, reduced overall by 80%. That's from the Western area. We've also got back 17 years ago when we first came into Interflon, a gentleman called Richard Owens was one of the route directors for the Midland route. He actually wanted to keep people off track, very much a bit like the safety task force is doing a very good job of doing now. So Interflon have thought about this over the years, and we've actually designed a dispensing system. So effectively, you can put this onto switches. It can treat up to 2/4 ends under one single system. It sits in the cess. You fill it up once a year, and it can actually put lubricant onto your slide chairs. It's actually in development now because we actually did show you shortly. So yeah, it applies new BP. We actually developed this system 6 years ago. It actually went out in track. It was very successful. It was just about ready for being signed off, but then Network Rail lost its way of what it wanted as a priority, so it shelved. We've now brought it back out now. We've moved to newer technologies. We've made the system even better. And again, it does work very, very well. It's a clip system, so it clips onto the track. It only takes 30 minutes to actually install it. Likewise, if you tamp it, it's not a problem because everything sits inside the forefoot. Likewise, as well, if you're actually changing a set of switches, you can undo the clips, put your new set in, and re-clip it back up in 30 minutes. And this product is actually being looked after at the moment by a gentleman called Tony Wright in the TA. So if anybody's interested in that, Tony Wright's the gentleman to speak to. So what benefits does it offer the S&T guys? So these are the HWs and 63 machines. We was asked by Scotland whether we could transfer their lithium grease onto our lithium-based grease material, but again, a dry coating. And this product's called OG grease. Spray it onto the open gears. Okay, this is the difference that it makes on the graph. Again, it's a very thin, dry coating, but one that does reduce friction on the gears as well. That's fully been tested, so everything's got product approval. Switch tips. So this is where traditionally the guys have gone along and they put 3 dabs of grease onto the front of the switch, and then relies on the flange of the wheel on the train to actually spread it through the switch length. With our product, you don't do that. You spray it all the way through the head planing length. Again, this guy's just going to quickly show you just in front of the switch, and then through the switch all the way through the head planing length. And again, this forms a dry but transparent layer. Okay. So this product's now been approved for this application, I think over the last 6 to 8 years. I think it's also part of the Network Rail specification to use this product. Showing you here on the right hand side, that's actually got it coated, so you can see it's completely transparent. Obviously the guy at the top there spraying it. This is an email that came from a gentleman called Phil Crowder, basically saying the performance of the product has actually made a big improvement to his failures on his switchblades. So his PM failures had massively reduced. Just to give you an idea, this is the data that's come back from the East Coast Main Line, so from Doncaster. So they've been using the product since 2018-19. You can actually see the failures and the weld repairs they were doing on switches prior to using Interflon, and now vastly reduced. Again, from 8 down to 0, from 5 down to 0, 10 to 0, 7 to 0, 3 to 0. So again, it clearly shows you that it works. So it reduces the lateral loads and the contact fatigue you get between the flange and the rail. Schwiag rollers, again, East Coast Main Line and quite a few of the S&T guys now using Schwiag rollers. It can actually rejuvenate the lubrication side of Schwiag roller, but also if you've got a failed roller out in track and the S&T guys are out there to go to the failure, you can actually get a failed roller running in track. And that's the actual graph there. You can see it before and after. It seems to be a general use product now, and that's FinLube TF. Again, this is LNW South, so this is the Bletchley EU area. This is data coming back from the IME, and you can see that they obviously will challenge to beat the target by 20% on the failures that we're getting on clamp locks. What did they do? They completely changed everything over all the clamp locks to these Similube systems. So this is an automatic lubrication system for a single point lubricator. If it's up in the air, you can put it up there for a year. You can pipe it down to ground. It's got enough power to be able to get lubricant to wherever you need to get it into. This can actually, deploy oil, or it can deploy grease. Fully reusable. So again, once it's dispelled, you can fully refill it. It's filled with a hydrogen pack. These systems are made in Switzerland, extremely good. If you've got areas where you've got flooded components, again, these things work underwater. But again, this is what LNW South completely changed over to. In areas where they hadn't got sufficient bodywork here, they're actually using Interflon on its own without the Similubes. But as you can see, what did they do? They actually went from 28th mean time between failure to 7th. Again, it shows you the products actually made a big difference to performance. Again, these are on cranks. So again, the products can be used on cranks. And again, LNW South have been using it the longest on cranks. They've gone from failures to 0 failures on cranks. Barrier pedestals. Again, you can use the product in barrier pedestals. Again, fully approved. And then the next application is fish blades. So there's a lot of fish plates up and down the country. Traditionally, you would back off the bolts, pull the plates apart, clean everything, put new lubricant in, bolt everything back up. That's normally a 4-man job, 2 teams of 2, and that takes roughly 20 minutes per joint, something that they have to do every year. Yes, so you go from 20 minutes a joint to 30 seconds, 97% efficiency saving. So as you probably noticed there, even myself, it was actually lubricating the joint. You don't need to back off the bolts. Again, it uses capillary action. No matter how tight the bolts are, it will actually get in. Roughly takes around about 50 minutes to penetrate in. I'll show you a little video shortly to no music to add on. To show you how well it actually penetrates in. But the areas have started to use this already and had some fantastic results. What we also found as well was, which we wasn't expecting, there was a graph in there that showed you if you traditional black grease, the load between the fishing surfaces was around about 23 kilonewtons. When you actually clean that out, put Interflon on, it drops from 23 kilonewtons down to 2. What we found in Wales was when we actually did a full stretch, was around about 15 miles. We also found that once we started lubricating every joint closed, we actually found that the track started to regulate itself. So that was an added advantage that we wasn't expecting. Yeah, it will actually self-regulate. The 10-litre drum will do about 125 joints. All you need is a backpack and the 10-litre drum, and away you go. There is actually also a process to change over the bolts as well, because obviously every time you run off a rent lock nylon bolt, or nut should I say, you have to replace it. I'm not saying that happens, but you're supposed to replace them, and that's because obviously you lose a lot of torque on the thread because of the nylon's already cut. There is a product out there from State Art called Hard Lock, which actually don't come down under vibration, and the results we're getting back so far is everybody's really happy with them. Again, once you do a conversion, then you will not need to open up any joints or tighten up any balls. So first of all, it's 20 times less in force. So I say 23 kilonewtons down to 10. You can actually lubricate without opening the joint. It does take one person 30 seconds. It's roughly about 50 minutes. If you just open up the joint in 50 minutes, you'll see it's on every fishing surface. So you can upgrade stretches of line from black grease joints to dry film joints. It's recommended that the approach is taken to upgrade every fit joint. There is actually a derogation from engineering to do a complete changeover for hard lock nuts and Interflon. This is just showing you how well it penetrates. We've got product and food dye here. Yeah, so that was obviously a bush and a pin tightly closed. Bit of product with a bit of food dye, so you could see it, and obviously just sped up. So yes, it's an exceptional product to getting into anywhere you need it to get into. Obviously, the guys in the room are going to get a sample. You guys weren't here; you would have got a sample to try. But yeah, it's an excellent penetrant. These are the hard lock nuts. Don't know whether the OLE guys have started using these. I certainly know there's been an inquiry about using them because there's been some issues with bolts coming on them. These do not.
I'm not aware of anyway.
Okay. Well, as I say, they are looked at now on the OLE. So what you've got is you've got an offset cam. You've got a concentric top. Effectively, as it shows you here, it's pushing this way. It's also pushing up as well with the threads, and it locks against the cam. If for whatever reason through vibration, the bottom nut turns, it tightens back up. It tightens itself back up against the cam again. These are actually used out in Japan, been used out in Japan for the last 30, 40 years. No issues at all. They're also used on stretcher bars after Potter's Bar. All the stretcher bars that are in S&C. Yeah. So again, if you used to put nuts and bolts upon the OLE, they're not going to come done under vibration. So this will be some vibration. And then we've got we're in the autumn season now. We've got a leaf cleaning product called OTR. This was a bit of a challenge by Steve Featherstone back in the day. to come up with a product that was good on cleaning leaves and was as good as on slide chairs. So it sort of got us thinking, and we started to look into, well, is it just the leaves that we need to clean? Because if you're just cleaning the leaves, you're just being reactive. Okay, so we thought, no, it's not about just cleaning leaves. Well, the other thing we need to do is we need to be able to keep the product on top of the railhead for some time. But also as well, we need to take off the oxidization, because if we take the oxidization and rust off the railhead, we can actually increase the friction. Okay, so we normally used to go in the other way. We're increasing friction. And we developed this particular product. So what this product actually does is you apply it to the railhead, it gets into the pores at micronized levels, it stays in there, and it sucks any moisture in from the air. Once it sucks the moisture in from the air, it keeps reactivating and reactivating. It keeps cleaning the railhead, and we've had fantastic results of this particular product. It's 98% biodegradable. We use organic material, so again, it's very green. But I'll show you a couple of videos in a minute. So it quickly removes organic leaf contamination, oxidization from the railhead. It reduces the adhesion issues, low risk wrong side track circuit failures, and it only takes about 1 to 2 minutes to actually clean any contamination off the railhead. I certainly know when the RHTT trains have gone through the track, depending on speed, depends on how good the quality of cleaning is done. But this thing really is very, very quick, and it stays in that condition for some time. No need to rinse with water or wipe the product. It's self-clean, cleans leaves, micro layer, which activates with rainwater moisture or any RHTT train. So one of the other things that we found as well was because it actually fits into the pockets of the railhead. When you get the positive pressure from the RHTT train, it actually pushes a positive pressure on top of the rail, sorry, on top of the pocket. So it keeps the material in. Effectively, it puts the lid on the top of the pockets. So it does keep the material on there. Surface stays clean for longer. It does not damage steel, rubber, plastic or reflective coatings. It's safe to be used around cabling, insulators, pads and speedboards and signage. Product reduces the time it takes to clean the railhead and therefore reduces degradable working and delays to passenger travel. Allows seasonal teams to restore track circuits which have failed wrong side and therefore reduce the risk of further safety events. What we found that people that tested it last year actually got a layer of this product on before the leaves fell this year, and actually they found that they've not had any leaf contamination issues to date. So this is just going to show you now how it works. So this one here to the right is going to show you how effective it is and how easy it is to apply to the railhead, and it literally is drops. You put very small quantities on. If you apply it by, which they're going to do next year, an MPV train, it's roughly 1.5 litres per mile. So it's very small quantities. And on the bottom here, we're going to show you how the rejuvenated layer still will remove leaves very, very easily. So I'll do this one first. So this was applied 10 days earlier. Stop leaf contamination on the top. It's rejuvenated itself in a quick wipe. It literally brings any leaf contamination off. And again, RHTT training will just take everything off. And here to the right, been applied through a pram. See the black layer of leaf contamination. This rail we did earlier, 5 minutes earlier, 2 minutes earlier, sorry. You can see the amounts go on. This rail we did 2 minutes earlier. You can see the difference. It is that quick. If anybody's interested in that, they want to reach out to me, I can put you in contact with Network Rail people that are guys on the ground that are using this stuff all day, every day. They'll be able to give you their experiences. Again, this is from Middlesbrough. Shows you the befores and the afters. Okay, and that's after following 10 minutes. Really does work very, very well. You can also dilute this product with water. So if you've got heavy contamination, you can put it on neat. If it's not as heavy contamination, you can get away with diluting it 1-to-1 with water. This is from the information from Middlesbrough. Again, this is from Doncaster. Can be applied and then only a water carried approximately 10 days. Very good results in Doncaster. And they actually got to 25 days between applications in Doncaster as well. Okay, thank you very much. Any questions to the floor?
got a question. With the pad, is there any electrical problems with it? Obviously, you've got track circuits and things, and
Yeah.
it's got the layer that we're adding in between the rails.
Yeah.
Is that causing any problems with the track circuit and detection?
No. No, track circuits have stayed up when this problem's
Nice.
been applied and stayed up for some time.
Seems like a miracle. Go back to the.
It seems too good to be true.
It
doesn't it?
is, it is, there is a little bit of that.
And that's why we always say to engineers, you try yourselves. Don't
Yeah,
believe
yeah.
us, try yourself. We can put you in contact with lots of people around the world that use the product. The biggest thing, I suppose, from our point of view is people, you've got to want to change. You've got to want to look at new technology, and there's lots of new technology out there. If you're interested in change for the better, then Interflon's an ideal partner to work with.
Do you find operatives tending to over apply it because they used to sort of spray and pray?
Yeah.
Kind of lubrication.
Absolutely, and that's why we insist that we keep going out and retraining. Because at the end of the day, what you'll find with this product is you'll put small bits on and it works. Initially, when you put it on, you think more's better. It's actually the other way around. Less is more of this product. So yeah, we do educate people on a constant basis, and also as well, we train the trainers, so they also know exactly what they're training out. And we also get a lot of people that will come to us, the guys on the ground, that say, do you know what? We've tried it on this and it really works very well. You know, we're happy to support them going to engineering and saying, you know, can we use it for this, etc. Obviously, we toe the line with regard to what engineering approves, so that's what we've always stated. But yeah, you've got to want to change for the better to take on this type of technology. It's more expensive, but you use a lot less, normally 90% less. With regard to the environment, because you're using 90% less, and we use renewables in our product, it's a greener product as well.
If you had an existing installation that was covered in traditional grease, presumably that's got to be completely clear.
It's got to be cleaned off. Now, one thing I forgot to tell you was in the main Lube EP product we use for slide chairs, we've built a cleaner in it as well. Not a degreaser, but a cleaner. It will clean out any contamination. It will de-rust itself. As long as it's contact, it will bring anything out. And we actually get the guys as well, instead of actually using degreasers now, every time they apply a product, they just use a bit of this product. It just cleans anything off and away we go. So it is a multi-product. Any questions from the guys online?
Yeah. Does anyone want to come on, sorry. Does if anyone's got any questions online on the for the floor, would you like to raise your hands and I'll.
Yes.
No.
See, they've gone very well. Very happy.
Well, thank you, Rob.
No problem.
20 people dialing in, so.
I was going to say thank you very much. I found that very interesting. Gary's going to want some to put on his bike.
Yeah, we'll get to it.
So thank you very much. And in that case, we'll ask everyone to thank Rob in our normal fashion.
Yeah.